Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, I'm really excited to bring you today's topic, which is satellite communications using a Horner OCS. And the reason I'm so excited is because over the course of my career, which at this stage is 30 years in, I've never really had an opportunity until recently to work with satellite transmitting equipment. So I've always wanted, especially in the last few years, to work with satellite modems, and I had a customer reach out and give me the opportunity to work with the equipment, and we're going to use it for today's demonstrations. And to help me talk about satellite communications, I'm going to bring in our product manager, Casey Gardner. How you doing today, Casey?
Hey, not too bad. How's it going, Chuck?
Going terrific. So I just said I haven't had a chance until recently to play with the satellite equipment. How about yourself?
Yeah, I think I've had one project I did a while ago. It was kind of more of an R&D project where I had messed with a Globalstar modem. It's not too long ago.
Yeah, so I've had a chance to work with an Iridium setup, courtesy of a customer, Dulon. Thanks, guys. And I found it pretty good. I mean, in terms of easy to work with, right? So we'll go through this in the content, but you know, it has RS-232 port built in, so we aren't messing with any kind of TTL level signals, which I think is something you were going to have to deal with. Is that right?
Yeah, that's the case for sure.
So that, you know, so then you need a TTL to 232 converter. It also had a couple signals which we could monitor. One of which was really handy was network available. So, you know, when you've got a satellite system, you don't always have coverage 100% of the time. You can have some brief periods of blackout, maybe a few seconds or something, or a few minutes. And by having that signal to monitor, you always know when at least you've got a good shot at getting your communications going. So that's probably something that you didn't have a chance to work with. Is that right?
No, I mean, that's definitely a really nice feature to have. Kind of lets you build in your own kind of store and forward technology if needed.
Exactly. And another thing I found, which really wasn't a matter of playing with the equipment, but more of a fact of doing a research and talking with the customer, it's not as expensive as I thought it would be. I thought it would be hundreds of dollars a month, and it can be if you use tons of data. But from what I've understood, you could have a monitoring system using satellite for a key asset, and you could be looking at less than $50 a month. That's pretty good.
Yeah, it's pretty reasonable, especially you see it. I mean, there's some applications where the customers may go to try to all lengths of wireless communication over multiple miles or something like that just to get away from those kind of monthly fees. And I mean, for again something that reasonable, that's more understandable for sure.
Yeah, and with gas prices these days, right? Another alternative that this beats is having to drive to the site just to check on it. When you're not even sure if it's working or not.
Absolutely.
Okay, so I'm going to go ahead and present the material and give the demonstrations. Meanwhile, Casey is going to be standing by. If you're watching live, give us your comments and your questions in the chat section. If you're watching on replay, like a lot of you do, give us your comments in the comment section. All right, let's go ahead and get started. So what is satellite communications is where we're going to start. We're going to talk about different applications for satellite. We're going to talk about the functionality, the implementation, and we're going to do a demonstration. So what is satellite communication? So it's a network of low Earth satellites available as a service for communication machine to machine. So that's really what we're talking about here. We're not talking about satellite phones. We're not talking about high bandwidth type communications. We're talking machine to machine type communications. The kind of thing people are looking to do these days for the industrial Internet of Things, in addition to, of course, monitoring sites for health and to make sure everything's up and running. Satellite communications are really an alternative to more traditional network mediums, which in some applications just either are not available or they're not practical. So obviously, if we have access to a hardwired LAN or a cellular network or a 900 megahertz radio, in some cases those would be preferred, but there's other cases where the simplicity of a satellite system is really pretty ideal. Benefits of satellite communications. First of all, you can communicate pretty much anywhere on Earth as long as you've got line of sight access to the sky. That's a really big advantage, okay? Now, it's not necessarily going to work indoors, but if you've got a piece of equipment that's moving around or you've got a really remote site that does have access to the sky, pretty much doesn't matter where you're located, you're going to have the ability to have service, okay? It's also very cost effective for a report by exception type system. In other words, not necessarily for a poll and respond type architecture, but for a scenario where the remote site can call in periodically with status updates. It can be very effective for that. It's also practical even in applications where you might only have a single site or a single asset that you need to monitor. I was thinking maybe you'd need to have a whole fleet of equipment to make it worthwhile, and that really just wasn't the case. Also, as I mentioned in the opening when we were talking with Casey, it does save the costly milk runs, as we would call them, or the regular round of people going to the site just to check on it. Whereas if it's checking in every day and you are confident in its status, then you can eliminate that, which eliminates a lot of cost. And of course, because it does report in periodically, you can quickly determine when you've got an issue and you can minimize your downtime. Okay, so the types of applications that we're talking about, of course, remote equipment, whether we're talking about a tank farm or maybe a remote pumping system, or maybe an injection system. You know, in some cases, when you have natural gas pipelines and things, you need to inject chemicals periodically to put the smell in the natural gas. And so you'll have these tanks periodically that are injecting the chemicals. And it's good to know how much chemicals are in each of those tanks without necessarily having to send a truck around just on a routine basis. Now, this is also, satellite that is also really attractive in mobile applications and also in marine applications. Okay, let's talk a little bit about the differences between low Earth orbit satellites, which is really what we're talking about here, and geosynchronous satellites, which are kind of the traditional satellite approaches. So the geosynchronous satellites are the ones that are in fixed orbit, and they're very large, and they're much further away from Earth. So in other words, they've got a much greater distance between the Earth and their location. And ironically, the further they are away from the Earth, the actual slower they actually have to go in order to maintain their orbit. So that was something I didn't realize before. The closer satellites do go at a much faster speed, potentially 17,000 miles per hour. That's moving around pretty good. Now, from a coverage standpoint, because those geosynchronous satellites are more or less fixed in place relative to the Earth, they don't give you the coverage of the entire Earth. Now, they can give you a wide coverage area, but not the entire Earth. So the beauty of having a network of low Earth orbit satellites is you could have, let's say, 60 or 70 satellites that are orbiting the Earth in a more or less coordinated fashion, and that can really give you complete coverage. Now, you can have moments of time when you don't necessarily have coverage, but those are just brief, and in a matter of a few seconds or a few minutes, you'll have coverage again. So you're never without coverage for too long. Okay, now there are a few different providers of satellite technology, and we'll just do a quick comparison of these here. Basically, you've got Iridium, Orbcomm, and Globalstar, and they differ in their networks, their coverage, the types and size of messages that they specialize in, and also in delivery time. So I've been working with the Iridium system over the on and off for the past several weeks, and I've been impressed with how quickly it does deliver the messages. So from the time the OCS sends a message, usually it's within a matter of seconds that message has been received and then passed on to my inbox on my email account. So pretty impressive, and we'll try and demonstrate that for you today. Okay, let's talk about the components of an OCS-based satellite monitoring system. What components would you need? So you're going to obviously need an OCS controller. That's going to be monitoring the site, whether it's monitoring well levels or tank levels, or whether it's, doing some control, whatever you need the OCS to do at the site from a control and monitoring standpoint, you would pick the appropriate OCS for that job. And then you're going to need a satellite modem for the system that you're using. And in our case, we're going to be demonstrating Iridium. You're going to need to have some sort of power system on site. So, maybe it's a location that it's remote and doesn't have good communications, but it might have a traditional grid supplied AC power. Or maybe you have a generator on site, maybe a natural gas generator or something of that nature, maybe a large diesel generator, who knows. You could be using solar power. That's definitely feasible in these applications. And, solar power systems, of course, also have batteries involved. So what's the implementation look like from the time you effectively pull the trigger on a system to the time you get it installed and implemented? Well, let's take a look at that. So you're going to start by installing the monitoring system on site, as you would expect, right? So you're going to have a control panel with an OCS and whatever other control equipment is required to monitor and control the application. And of course, also included is going to be a satellite modem as part of the system. So after you've got the system installed, you need to activate the satellite modem with your service provider. So that usually means a value-added reseller who's authorized for that service. And that's how, when I have been working with the Iridium system, I'm working with a authorized VAR for Iridium. So after you've got your satellite modem activated, next it's all about doing a little bit of configuration on site, making sure that whatever conditions are causing alarms to occur, that you've got those configured in the system. And then if there's any details of the data you're going to be sending for, when the alarms occur, or even just on a routine basis, you may need to do a little bit of configuration on the message contents. And keep in mind, when we're talking satellite communications, we're talking a few bytes at a time. We're not talking about, hundreds of bytes or kilobytes. We're just going to send a few bytes, which is going to either advertise the fact that everything's good, everything's healthy, and here's our current status, or a few bytes that also, if necessary, communicates the fact that there's a problem on site and it's going to need some sort of attention. Okay, let's talk about how the messages are delivered, okay? Again, we're talking about a few bytes, but we are talking about a message that needs to be delivered, and there's a few options available. So one option is you can kind of do a roll your own type approach where when you work with the VAR, you basically just specify, hey, I've got an IP address and a port number that I want you to deliver the messages to, and then I'm going to receive those messages at that IP and that port, and I'm going to do everything required internally in my facility to process that data. So that's one approach you can take, kind of rolling your own data handling, if you will. Now, you can also contract with your VAR to have the message delivered via email. That's very convenient, and that's what we're going to be demonstrating for you today. Also, you can contract with a web SCADA vendor. That's also very typical. And there's usually coordination between your SCADA vendor and your service VAR to make sure that the messages that come in are ending up in the appropriate web pages that you've contracted for through the web SCADA vendor. Another approach that is possible is you could also arrange for the messages to be delivered to an MQTT broker. Now, that may require some configuration on your own, kind of the roll your own approach, or that could be a service that you could see from Horner in the future. So we'll see where the future brings with that. From a daily standpoint, what does it look like from a communications? Well, first of all, you're going to have a standardized message, again, of a few bytes. And if everything's working well on site, the standard operating procedure would be that that standard message is going to be sent as a health check once per day. So at least once per day, probably once per day, you're going to receive a message with, it's going to be the standard message with the standard data communicating the status of the site. And you're going to be able to tell from that message, everything's talking, everything's working, everything looks good. Now, however, if you do have an alarm that gets triggered on site, it's also going to send that standard message, just going to send it on demand. So you're going to receive another message that basically gives you the details on what needs to be responded to. And again, as we talked about before, the messages are going to come in as you've prescribed them, whether that's to an IP address and a port number, via an email, as a web attachment, through a web SCADA approach, or maybe through an MQTT type approach. Okay, so let's talk a little bit about the types of data usages we're talking about and some examples on what costs could look like. So really, for a report by exception type alarm monitoring system like we're talking about, you're probably looking at less than 4,000 bytes of usage per month. So think about that. 4,000 bytes is all we're talking about. But that's really all you need to be able to communicate on at least a daily basis the health of a critical site and avoid someone having to drive from site to site to site just to check on it. Now, the plans that are available for this sort of system, typically you're going to be looking at less than $50 a month for a system that effectively signs you up for that 4,000 bytes per month and daily emails at the very least, and emails when you have alarms. So that's pretty economical. Now, if you're going to be handling all your own data and not be signing up for email service, then that cost is going to be a little bit less. If you're signing up for custom web pages from a web SCADA vendor, I'm guessing the cost is going to be more. So certainly, again, these costs are much less than your milk run expenses. Now let's talk about the specifics of interfacing an OCS controller with a satellite modem. And what we're talking about today is we're talking about the Iridium Edge satellite modem that I've been working with, again, off and on for the last couple of weeks. So the Iridium Edge satellite modem is an IP67 package. It supports a wide temperature range. Now, it's designed so it has a 180-degree line of sight. So if you're partially obscured, there's still a chance to the sky. There's still a chance you could receive service there. So that's something to be aware of. It can be powered from either 12 volts or 24 volts, which is very convenient. It's got RS-232 built right into it, so that makes it interface easily with things like Horner OCS products. And it's got some control signals that we can monitor and some status signals so that we can see what's happening when it comes to if we're ready to communicate or whatever the case may be. Okay, so I'm going to go ahead and show you right now. I'm going to show you a little short video I recorded, kind of showing you the hardware in person. Let's take a look at this Iridium Edge modem that I've used today for our demonstration. So as you can see, it's quite compact, about the size of my hand. It comes in an IP67 package, so it's protected against the weather. You can mount it a couple different ways. You can use M4 screws here in the four corners. It also comes with adhesive pre-installed that you can take advantage of as well. It has a single cable. It is an M12 by 8 pin connector that accepts all the power connections and the communications connections and some other signals. And you can orient this a couple different ways. You can mount it like I did, with the modem above and the cable coming straight out from the bottom. You can also reroute the cable to the side if that works better. So once again, this is the Iridium Edge modem. Really compact, really nice package, and quite easy to integrate. Really nice package, as I mentioned in the video. All right, let's talk about, in a little more detail, that pinout on that M12 plug that has 8 pins on it that allows us to interface with it from the OCS. So the pins available include, of course, the pins required to power the unit, the RS-232 signals for communicating with the unit. There is an input on the satellite modem that you can use to switch it on and off. This is useful if you need to turn the modem off to save battery, for instance, in maybe a solar application. Maybe you only want to power that modem up when you need it as opposed to leaving it on all the time. So you have the ability to do that from the OCS using that signal. And then you've got a couple of signals that tell you the modem's powered up, and it also tells you that the network's available and that it's okay to send a message. Okay, now the specifics of where the connections are made, I've got those on the screen here. So obviously the RS-232 signals are going to be connected to the RS-232 port that's available on your OCS, and every OCS has RS-232 available for it. It's usually MJ1. And then you've also got those 3 signals I talked about for switching the modem on and off. That's a DC digital output. And then for monitoring whether the modem is powered on or whether the network is available, for both of those, you should really use a 0 to 10 volt style analog in. There's some other options as well using some resistors, but the cleanest way is to connect it using a 0 to 10 volt analog input to monitor those particular signals. Now, I've installed a test system outside that I've been working with over the past few weeks. And I'm going to go ahead and play a video now that I recorded this morning that kind of walks you through what the system looks like. Okay, here's a look at our demonstration system. We have our, I believe this is a 16 by 12 enclosure. And we also have installed inside the enclosure or on the door, we do have a Horner OCS EXLW. It's a 6-inch. It's protected by this Rob Roy Stalin solar shield accessory. If you want more information on this accessory, check out our YouTube channel. We've got a live session that is available to you that we recorded a few weeks ago. So let's take a look inside here at the OCS. All right, there's our EXLW. The idea here is that we're simulating tank monitoring. We'll show this all to you at a better angle with more of a close-up later. And we've also got a test screen that we can use to verify that the modem's on and it's ready to transmit because the network is available. That means there's a satellite going overhead that's within our range. Also, we've got a test button so we can send a test message, and then we have a series of LEDs that we've drawn on the screen here to follow along with the communications going back and forth between the OCS and the modem as it goes through the process of first sending the message to the modem and then secondly causing it to be transmitted. Okay, so that's a look at the OCS here. Let's close this back up again. All right, next I want to show you the Iridium Edge modem. I just have it temporarily placed on here through a hole in the top of the enclosure. I didn't want to permanently install it, as you can imagine, because of the fact that this is a loaner. So, but it's up here and it's working well, and we're going to demonstrate this for you shortly. So this is our demonstration system for the satellite monitoring system. So before we demonstrate sending and receiving messages, I wanted to cover at least briefly kind of what the communications transactions look like between the OCS and the Iridium modem. So effectively, we're talking about RS-232 communications. We're talking about straight serial communication, so it's not a established protocol. At least it's not one where you would just select like Modbus or Ethernet IP. And there's a process that you go through, or that the OCS and the modem go through as they exchange data. And I've got it detailed there on the screen. So effectively, it starts off by the OCS turning the modem on if necessary, or at least waking it up, setting the communication parameters for the connection between the two. And then the OCS needs to prepare the modem to receive the message characters, because it's really a two-step process. Once the communication begins between the OCS and the modem, the OCS sends the message to the modem that is going to be transmitted. And then once the modem has received it, then it actually starts what's called a short burst data session to actually cause the modem to transmit the data over the satellite. So it's a multi-step process. And then once that occurs, you're either going to get a success feedback that tells you, yep, everything went through, or you could get a response that tells you you need to try again later, because maybe the satellite's available, but maybe it's busy handling traffic from another location. So in that scenario, the OCS is going to back off and then communicate again in a few more seconds. But the satellite modem actually tells it how long to wait before trying again. And again, we're talking typically about a matter of seconds here. Let's go ahead now and take a look at our system that I've got in the backyard. So that'll be kind of a live look at what's going on the system there. Okay, so you can't see the screen very well, of course, from this view, but at least you can see what's happening. I've got the system up, the cover is up on top, of course, and we're ready to communicate. Now, to really make this easier to demonstrate, I've decided to go ahead and utilize WebMI for this purpose. So let's go ahead and get WebMI going. So in addition to the fact I've got a satellite modem, of course, on the top of this control box, I've also got an Ethernet cable connected to my setup here at the studio so that I can remotely monitor and control that OCS over WebMI. Now, WebMI is not going over satellite. I want to make that clear. That's a hardwired Ethernet connection that I'm making for demonstration purposes. Okay, so let me show you what's happening here on the screen. So here on the left, I've got an area where we can type in a test message. And again, we're talking about, for this case, a test of a maximum of 5 bytes is what we're looking at. So we're going to send a message of XYZ over the satellite. That's the test message we're going to send. Now here, this is where we can monitor through analog inputs the signal saying, is the modem on or not? Well, in my application, I'm leaving the modem on all the time. It's not a battery application or anything, but this is giving us confirmation that the modem is on. And then there's a network ready signal that I'm monitoring through another analog input. And when it has a value of 3 volts, it means the satellite is ready. the system is ready. And you might see this actually turn off while we're doing this. It does turn off periodically depending on locations of satellite in the sky. So it happens to be on right now. Let's go ahead and see if we can send a message. So I'm going to hit the send message button, and you can see down below the transactions are moving from step to step. And when it gets to step 8 there in our transactions, that's where we're either going to find out from the satellite modem that the system was available and we were successful, which we were, or it could tell us we need to try back again later because of load sharing type scenarios. And in that scenario, we would have gotten a red light. But we did get a success light, which tells us that we should be getting an email. And sure enough, I did get an email. And let's take a look at that right now. So it came into my phone through my email, and you can see there's an attachment on that email. This came in from Iridium. The attachment, if I could open it on my phone, and I don't have the right app on my phone to open it, it's just a text file, but it has a different extension, so the phone doesn't really know how to handle it. But if you open that file, you would see that it's a file that basically says XYZ. Now, in a real application, you're going to make a tie-in to the message that's sent to, of course, the status on the site. So those characters that are sent are going to represent data, maybe well levels, maybe specific alarms that are on, maybe temperatures, if that's what you're monitoring. So there would be a real world tie-in between the messages that is sent and the actual status at the site. For my testing here, I just sent a test message, which was XYZ. So that's what happened there. So anyway, that's what it looks like when you are getting email delivery of the messages that are sent from the site. So let's go ahead and wrap up our topic for today. So satellite communications absolutely can be a viable alternative to more traditional communications options for a remote site. So maybe you don't have cellular service, maybe a 900 megahertz radio system would not be practical, or maybe just too expensive. And of course, you may not have a hardwired LAN available either. So satellite is absolutely an alternative you should consider in those scenarios. Also, a Horner OCS as a compact low-power controller is an excellent choice to pair with a satellite modem for reliable remote monitoring. This is at the point in the program where I remind you that we are here every Tuesday at 2 o'clock with another topic. Today we're fully live, and so far all the demonstrations have gone pretty well. Always exciting when you can do a lot of things live and it all seems to work, right? That's always what we're all looking for. A reminder, we're also celebrating our 10th year of Horner Lighting Group products. So check out lots of great lighting videos on our YouTube channel alongside our great automation content. For next week's or next month's topic, I should say, including next week, because next week is next month, you can check out our website and you will see soon, at least, specifically which topics we're going to cover during April. So again, we're here every single Tuesday, so you can be guaranteed we've got some great content for you. Okay, so before I sign off, let me remind you, if you haven't done so already, don't hesitate to subscribe to our channel. It doesn't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. Okay, so until we meet again, which should be next Tuesday at 2 o'clock, let's all get out there and do us some good.